Hi, my name is David. Today we're going to do a HackerRank problem, 2D array in the arrays section of HackerRank. This is an easy level problem, and we're going to solve it in JavaScript. So you're giving a 6x6 2D array, and they want to know an hourglass within it, which is a subset of this array. So it'll be this, this, and all of them. So this, and this. Every single hourglass capable within inside of this one. So for this example, this is the example input, and these are all the possible hourglass sums. And it wants you to return the highest sums for this problem. And let's do it. So this is a weird way to look at it because it didn't make sense to me. So ideally, how you should picture it is that this is all an array, and inside this array it has these sub-arrays in it, and there's commas in between all of these, but you get the idea. So it's one big array with arrays, six arrays inside of this one array, and each of these arrays inside of the array has 6 values inside of it. So that's how you should picture this problem. And then to solve it, you first have to create a value to hold the sum. Create maxSum variable. And there's a constraint here that is only can be between -9 and 9. So the lowest possible one would be -9 times 7. This is 7 values in each hourglass is -63 to -63. And next, we want to loop through this. And we know that we can only loop through it 4 times. 1, 0, 1, 2, 3, 4. Because once we get to here, it's not going to be a number. It's outside of the bounds. So loop through. So first we have to loop through the rows and then the columns. So we're looping through here, the rows, until 4. And inside of this loop, we want to create another loop, columns, and until 4 as well, because once we get to the bottom here, 0, 1, 2, 3, we don't have to, it's outside of the bounds. So once we have these loops down, we have to calculate the values. So you create to keep things organized, a top variable, and set it equal to these values, to top hourglass value to the sum of top hourglass value. Create middle variable for the middle value. Create bottom variable for the sum of bottom values. And once we get these values, we find the max of the maxSum, or the top middle bottom added up. So we're gonna add all these values, and if it's greater than the starting one, that becomes a new maxSum. And lastly, once we finish this loop, we return maxSum. Okay, so to code it out, that maxSum equals to negative 63. Now we loop through for the rows first for that I equals 0, I is less than 4, I plus plus. And now we create another loop within it for that j equals 0, j is less than 4, j plus plus. And inside of this, we have to get the sums of everything. So let top equals array. So this signifies this row, and then we get the other one, sorry, it should be I, and then this one, j, will be showing this index, and then you add it to j plus 1, which will show this array at this one, and then lastly, array I, j plus 2, and I'll get this one. And now you do to the middle equals, and now we have to go down one, so array I plus 1. And then for the j, it'll be j plus 1 as well to get this one. And then for the middle, it'll be kind of similar to the top one, let bottom equals array. We'll have to go to this one, so I plus 2, and then j. And then we do the same for the values of the bottom. And then, so now we get this, see if there's a new maxSum. So maxSum equals math.max from maxSum, or let me create a new variable for this. Let current sum equal to top plus mid plus bottom. Put this inside of here. And lastly, we return maxSum. Okay, let's check. Nice. So for the optimization complexities, we know that we're doing a loop here and another loop here, a nested loop, so it'll be O of n squared. Even though we're not going through an entire thing, it's the closest to it. And space complexity, we have to look at our variables, what we're holding on, and it looks like it's going to be constant, so it'll be O of 1. And that is how you solve this hourglass sum function. Thank you.